Recording in progress.
So this is the question 6 of the chapter 7 review on part 2. So it's still chapter 7 review part 2. However, this is on naming acid. And naming acid is actually covered in chapter 5 in the textbook. But when we covered chapter 5, I didn't include naming acids. And it's included here because when we go over the acid-base reactions, then it was easier to have it here. So when you need to name acids, you know, when you have the formula or the name, you need to decide if you have what we call a binary acid or an oxyacid. A binary acid is when it's made of just hydrogen and a non-metal, like HCl, for example. Oxyacid is made of polyatomic ion. So remember the polyatomic ions. So it's one of these polyatomic ions with the H plus hydrogen. Together, they can make an acids. And so these are called oxyacids because notice how most of them have oxygen in them. So that's why we call them oxyacid, because of the oxygen. And so they are named differently. And so first you need to decide, do you have an oxyacid or a binary acid? So here, when you have H2SO3, for example, you recognize that you have a polyatomic ion and it's going to be the SO3 part of it. So it's always H plus, you know, the positive ion, because let me emphasize that acids are molecular compound, but they behave like if they were ionic. It's always making the H plus ion, and then the other ion is the negative ion. So here, if we look at the list of polyatomic ion and try to find the sulfite, well, I mean the SO3. So the sulfite is here, SO3 -2. So we know now the charge on SO3, and it's 2 negative charges. So the 2 negative charges are a superscript. The 3 is a subscript. So that's the 2 ions that make up this acid. And so the way we name oxyacid, so it's an oxyacid because we have a polyatomic ion with hydrogen. And so you take the name of the sulfite here. Remember how it's named sulfite. So it has the ending -ite. And when you have the ending -ite, so let me write that it's sulfite. This is the sulfite. And when you have the ending -ite for an oxyacid, you change it to -ous. So we change it to sulfurous. So for sulfur, you know, sulfite, you go back to sulfur and then you add the ending -ous. But if it was nitrite, for example, you would say nitrous. But for sulfur, you need to go back to, you know, from sulf here, from sulf, you need to go back to sulfur and then add the -ous. So sulfurous will be the name, and then you just add acid. Acid refers to the H plus. So that's it. For an oxyacid ending in -ite, you change the ending of the polyatomic ion name to -ous and then add acid. So that's the name of this first one, sulfurous acid. So now HF. So I told you we need to decide, do we have a binary acid or an oxyacid? And here you have only one non-metal. So that's what we call a binary acid. Yeah, let me write above here that we had an oxyacid. Oxyacid. So it's a binary acid this time because we have only one non-metal and then H plus, right? It's made of H plus and then F minus. F minus is the fluoride, right? So for binary acid, you need the root or the prefix hydro. So you need the prefix hydro. And then you take the name of the nonmetal, so fluoride, but you change the ending to ic. So fluoride becomes fluoric, and then you add acid. So it's hydrofluoric acid. Hydro indicates that it's a binary acid made of just fluorine. So this is fluorine, fluor, and then the ending ic. So hydrofluoric acid. H3PO4. So here we recognize the PO4 as a polyatomic ion. And hopefully by now you recognize that it is the phosphate. So let me just write that this is an oxyacid made of H plus and PO4. So let's look at the list of polyatomic ion and find PO4 here. PO4 -3 is the phosphate. So we have the ending 8 this time, phosphate. So 3 negative charges. That's the formula of the phosphate. So let me say that this is phosphate. So from the phosphate, you will take phosphos and change the ending 8. So this time it's 8. So you change the ending 8 to ic. So it's going to be phos, and you change the ending 8 to ic. So again, for phosphate, the root is not just phosp, you add the OR again. So almost like phosphorus, but you change the ending to ic. And add acid. So that's how we would name this one, phosphoric acid, right? No hydro, there is no need for hydro because that's an oxyacid. And because the polyatomic ion had an ending in 8, then you make the ending ic. Now we have names, and so we need to find the formula of hydrosulfuric acid. So the hydro here, hydro tells you it's a binary acid. Binary acid. Binary acid means it's just H plus and then one nonmetal. And the root sulfur here tells you it's S, right? So you find S. And from the position in the periodic table, you know that sulfur is in group 6A, so it makes the -2 ion. So you take that as the ion that goes with the H plus. So it's the sulfide, right? That's the sulfide. So we, yeah, well, actually, I don't need to say that it's the sulfide. So the fact that it's binary acid means it's just those 2 ions. So then the formula of the acid will be H, and then the subscript of the sulfide will become a, sorry, the charge of the sulfide will become a subscript for H. And then the charge of the hydrogen here will be a subscript of 1 for sulfur. So it's just H2S. And we would specify here aqueous. Let me say why it's aqueous. It's because as an acid, H2S is aqueous. Every time you have, you know, in a text, when they talk about an acid, the physical state will be aqueous. Because H2S by itself, not dissolved in water, would be a gas. and that leads to gas evolution reactions. If you remember from the gas evolution reaction, H2S is a gas by itself. But when it is dissolved in water, it's the hydrosulfuric acid. Next, we have Ipo Bromus acid. So be careful, it's Ipo, not hydro, right? Ipo, so that means it's an oxyacid. We don't have the hydro prefix, so that's an oxyacid. So it's going to be made of H+, and then we need to find out the polyatomic ion from this name, Ipo Bromus. The ending us, so here the ending us tells you that it's, we use us when the polyatomic ion ends in "ite." So it tells you that it ends in "ite." So that means it's ipobromite. It's the ipobromite polyatomic ion that you need to find. You need to find its formula. So let's look at the list of polyatomic ion. So we might not have it here, but so what happens with all the halogens, you know, not fluorine, but chlorine, bromine, and iodine, they all behave the same way when they form polyatomic ions. And right now here you only have the ones with chlorine. You have hypochlorite, chlorite, chlorate, and perchlorate. And so ipobromite would be the same as hypochlorite except with Br. So here hypochlorite is ClO -1. So ipobromite is BrO -1. Because, you know, chlorine, bromine, and iodine behaves the same way when they make polyatomic ions. So that means ipobromite is BrO with 1 negative charge, according to what we have. So then we want to have H+. So H+ here. Let's rewrite H+. H+, and then BrO-. And so you see that you have 1 positive charge for 1 negative charge. So they cancel out, and you need 1 of each ion. And so ipobromite or Ipo Bromus acid would be HBRO. And then finally, carbonic acid. So no hydro prefix, so that tells you you have an oxyacid here. An oxyacid means, again, you have H+ with a polyatomic ion. The ending "ic" here tells you, so "ic" tells you that it's a polyatomic ion that ends in 8, right? Because whenever you use "ic" for the acid, it means you add a polyatomic ion ending in 8. So that means carbonic here comes from the carbonate. And so let's find the carbonate symbol. Carbonate, it's here. CO3, 2 negative charges is the symbol for carbonate. CO3, -2. CO3, -2. So the 3 is a subscript, and the 2 negative charges are a superscript. So that's the ion that makes up this acid. So if we write H+ with CO3, -2, so the 3 again is a subscript. So we have 2 negative charges for 1 positive charge here. So that tells you you will need 2 H+ for 1 carbonate to cancel the charges, right? So that means it's then, you can also do the crisscross trick to see that the 2 from the carbonate will become a subscript for H. And then the 1 from the H plus will become a subscript of 1 for the carbonate, which means there is only 1 carbonate. And when we have only 1 of the polyatomic ion, we don't use parentheses. So H2CO3 is the formula for the carbonic acid.